Okay, squares of a sorted array. Given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Okay, so basically as we can see in example 1 here, for example, nums, they might give us an array that looks something like this, and in basically increasing order, just getting bigger each time. And they want us to square all these numbers and return another array in increasing order as well. So what do we know about an array that's in increasing order? If it, well, considering that includes negatives as well, we know that the biggest values are going to be on the outsides of the input array, right? You can see 10 and 4, and then we got 3 and 1, right? If you take the absolute value here, as a negative, yeah, it's not the biggest, but square assumes absolute value, right? So basically, an algorithm we could do here, we could use two-pointer approach. We'll have a left pointer here at -4 and a right pointer here at 10. And we could look for the bigger, we compare the absolute values of both elements at the pointers, the respective pointers, and see which element is bigger. And that would be the first element we would place. We'd create a new array basically of the same size, and we'd fill in the spots. We'd basically choose like 10 first because it's the biggest. We'd fill that in on the right side. Then we'd choose -4. And we fill that in next, second from the right side. And then, yeah, and then we'd move in one. Or, is that how it would work? No. No. Actually, no. Here's what I think we do. We choose 10, like, because the negative, for example, could be like -4 might not be here. It might be -1, so 3 is bigger. So what we do is actually we do like 10 first, for example. We'd start the outsides, we do 10 first, because 10 is bigger than 4, and that would be 100. And then we would move this pointer in one, and we'd compare 3 and -4. Well, or 3 and 4 actually take absolute value, of course, and 4 is bigger, so it would be 16. And we'd move in like that until we've got everything. Okay, so let's actually code that out. Okay. So we have left is equal to 0, right's equal to length of nums -1, right? Yeah. Okay. So while right is greater than or equal to left, I think you'd have to be greater than or equal to right, because we'd have to get this value too. Well, we'll find out. I think this should work. Yeah. Okay, so also we're going to have to create a new array, which is going to be, we can 0 for now times the length of nums. Yeah. Okay, so it'd have the same, we'd have a zeros, we'd have a new array with like zeros to fill in the same length of the input array. Are we filling in new array, right? Okay, so what we do is, okay, we'd see, okay, if nums, whatever's that, right, or maybe I should get the absolute values first, like just compute it, or yeah, abs r is equal to the absolute value of nums of whatever is that, right? Abs L is equal to absolute value of nums of whatever is that left. So then we have the absolute values, and then, okay, so then we have if nums of right, we don't need to do this, right? We can just compare abs R and abs L. If abs R is greater than abs L, then we're going to new array, no, this is actually bad. why don't we just start at the end of the array and use I? Like, we'll start at the end of new array. So, for example, right, new array here in this example of fast5 would look like that. And then we would start the pointer here at the end, and we just move in 1 each time. And we just fill in the spots iteratively. I like that more. I like that more. For I in range, starting at length of nums minus 1. We can't go. This is so yeah. Go down to. Let's go down the array. Okay. So new array of. So the abs of r is greater than new array of I is equal to the. I guess we can just square abs of r, right? Yeah. Yeah. And we'd remove right in 1. Right? Else. No, wait. Would I handle... Yeah. No, I guess you would. I guess you would. I was going to see what if they were equal, but like then it wouldn't really matter, would it? Abs of L times 2. Or to the power of 2. And then left plus equals to 1. Just return new array. Does this work? Because new array let's see. This should work. This should theoretically work. Well, we'll find out. We're gonna find out for I in range. Okay. Okay. Let's run it once, and we'll see what happens here. Right? Can't confirm. Okay. It looks right. It works. Okay, that's the solution. So that's right. Okay, cool. Let's look at time complexity first, right? Okay, so we're going to iterate over the input array, the entire length of the input array here. So I suppose that would just be O of n. And for space complexity here, we have a new array of the same length as the input array, and we're filling that in. So since that's going to be the same length as input array, we're going to have O of n space complexity, and obviously, just to confirm that it's correct, I'm going to... Can I... No, I can't. Okay, never mind. I thought I could, like, examine the space or time complexity or whatever the fuck. Okay, yeah, I mean, I guess that's the solution, guys. Yep, hope you enjoyed.